In this video, we're going to be creating the code for our robots. We will be using Arduino blocks, which is a block-based coding IDE for the Arduino platform. That comes across a little redundant, but let's go ahead and move on. So when looking at the workspace here, what we have, this is our workspace where all of our code is going to show up. We have the setup function right here and the loop function right here. The setup function is simply a on-start set of instructions that as soon as we turn on our Arduino, everything in this setup area is going to happen just one time. The loop function, on the other hand, is a runtime loop that when we turn on our Arduino, it does the setup, then it does the stuff in our loop function, and then it's going to do the stuff in the loop function again. It just keeps happening over and over again until something causes the Arduino to cease functioning. As you saw a moment ago, I can click and drag to move this function anywhere I need in the workspace. Where it is positionally in this workspace doesn't matter so much. It's more of an organizational thing. It's not going to have an effect on the sequence of the end code. What does matter, though, is use this little nub right here at the top of each one of these functions. That's a place for us to snap in other functions. And these functions that are snapped in, the sequence of those functions between the top clip and the bottom of it, that's the order in which something is going to be executed when the function is called on. Over here on the left-hand side of the screen, we have our various blocks that we can drag and drop into the scene. If I click on logic here, we have our if statements and our comparison methods. Control, we've got various loops here we can do here. Math, we do a lot of math in programming, so we'll call on this one a few times. And then variables right here, this is where we can go to create variables or drag the variables into the scene when we're ready to use them. Arduino blocks makes extensive use of lists. Personally, I tend to use arrays, but lists and arrays are, for the most part, going to be functionally the same. Lists are much more flexible than arrays, though. Main benefit arrays get you is that they're going to be a little bit less intense on the memory if handled properly. Functions right here. This is where we can add in our own custom functions. We're going to do this for a few things. Custom function is just going to be something that we create. That's going to be a set of procedures that happen whenever that function is called on. Whether we're working with block coding or traditional scripting, creating your own functions instead of doing everything all in the loop really helps clean up the way your code looks and makes it more presentable and readable. Down here, we have various elements we can add in. Wait functions here. Down here on motor is one that we're particularly going to need. If I click on motor, DC motor shows right here. I'm going to click on that. For this particular project, we're actually using the L298 in motor controller, which is right here. If I drag and put this in the setup, that's going to do a big portion of our setup for the motor controller for us. If we were to do this in code, I believe this is somewhere around 6 different lines of code. In order to see how much code it actually is, if you click on right here, this pull down, and then click on view code, it'll show you what we added in. So right here, this is just declaring various variables that we're going to be using. They're all of the integer type variable. That's where the int right there. The name is horrendous. It's L298N_1_ENA, and then it's assigning a value of 10 to this first one. So we got 6 variables being declared. And over here, we're setting the pin modes for the various pins that this mode is directly going to be connected into. Now, those pins are not the ones I'm going to be using. I'm going to go ahead and close this out. Right here, this is our motor selection. Ignore this for now. ENA1 ENA5. Uh, these two parts of the motor controller, what they're going to do is set the speed of our motors for us, and then we have our inputs 1, 2, 3, and 4. Inputs 1 and 2 go with the encoder A, which is going to inputs 1 and 2 are going to help set the direction of our first motor, and then inputs 3 and 4 going with encoder B, and that's going to set the direction of our second motor. These numbers here actually represent the pin that it's connecting to on the Arduino. And for our example here, I'm going to change this one to 9, this one to 5, 4, 3, 2, and 10. So these numbers are not 100% random. I'm skipping pins 1 and 0 because pins 1 and 0 are used for our USB communications, and if we can avoid using them, that benefits us. So that starts off my numbering from pins 2 through 5. And then pins 9 and 10, the reason that's skipped there is because you'll notice on this pull down, there's only certain pins available. These pins are the ones that will allow you to actually communicate with the motor controller in the way we need. So the reason why that these pins are the only ones available is because on the Arduino, if you look on the sides of the pins, you'll notice that some of them have a tilde or a dash next to the number. That means that that particular pin is capable of pulse width modulation. Basically, the signal is going, the intensity of the signal is basically going to be done by sending a signal faster or slower rather than sending a signal stronger or weaker, because these are all digital pins, and for what most DC motors use is a analog method of being able to of controlling the output. Wow, that's stuttering. I apologize there. So generally speaking, on a DC controller, DC motor, if you want it to spin faster, you give it more power. If you want it to spin slower, you give it less power. If you want it to spin in reverse, you reverse the polarity. That's, in short, how a DC motor works. Because we're using digital pins in order to control it instead of a direct increase and decrease of the power, these pulse width modulation pins, what the motor controller that we connect to, the L298N, is going to do is it's going to take a look at how frequently the signal comes in, and then use that frequency to determine just how strong of a power output it should put out to the motor. A lot of explanation there. Sorry about that. Anyways, at the end of the day, pin 9 and pin 10, these are the ones that are going to tell our motor how fast to go. Pins 5, 4, 3, and 2, those are the ones that determine our direction. Next thing we want to do is I want to go ahead and create a list. So if I click on lists right here, and then click create list, I want this to be a number type list. It's only giving me two options, number and text. I'm going to click on that. It's asking me to give it a name. It says new variable name. Technically, lists are a collection of variables, but we have to give our list a name because that's how we're going to reference back to this list or call on it. I'm going to call this one input values. And if you can tell by the name, the whole purpose of this list is going to be to store in the values we receive from the controller. So I'm going to click OK. And then I'm going to drag this right here, and you saw it just snaps right underneath the motor. Whether we snap it above the motor or below the motor doesn't matter too much, just so long as it's in the setup section. Now, with our Flysky controller, unless we're using the UART communications method, we're limited to 6 different channels of input, or 6 different axes. Now right here, the default we see here, each one of these little nubs or these notches is going to be another entry point that we can put in on this list. If I hit the minus button, it removes some. If I hit the plus button, it adds it. I'm going to hit the plus button until I've got 6 of these notches, because I want 6 different places to store our input values. And at this point, I want to take the time to mention again, with programming, generally speaking, when we're counting, we start with 0 and we count up from there. So these notches, each one of them has an index value. Index value is just the address or the particular name of that part of the array or list. The very first one is index value 0, then 1, 2, 3, 4, 5. That's why in the previous videos I referred to each of the axes as axes 0 through 5, even though when you look at your controller, it's talking about channels 1 through 6. Just a little bit of a language and thought process difference between the people who made the controller and your average programmer. So what we want to do now is we want to be able to read our information coming from the transceiver of the Flysky remote to, read it in our Arduino, so that way we can use the axis value in our code. So what I'm going to do is I'm going to come over here to our input-output section right here, click on that, and we see there's various forms of digital read and digital write. We actually want to use read pulse. Here's read pulse. Drag this in here, and I'm just going to put it right here for the moment. That's not where it's going to stay, but what this is going to do is it's going to use the pulse width modulation method of reading the pins, so it knows our signal is going to be coming in rapid little bursts instead of one solid on or one solid off signal. And then we're going to get a different value based off of however fast that signal is coming in. With our pins here, we can read it from any of the normal digital pins, or we can read it from the analog pins. For this particular example, I'm actually going to read everything off of the analog pins. So A0, that's our first analog pin right there. I'm going to click on that. I'm going to leave this set to on. And looking at the timeout is in microseconds. Yeah, microseconds. Macroseconds. Pretty sure it's microseconds. Anyways, I'm going to set this number to 1 million here. 1 million is overkill. Let's do 10 million. In any case, it's overkill. It's way more time we need for the timeout. However, in testing out the code, what I found was if this number is left to the default value, sometimes we don't get a good read on the pulse width modulation, and it just doesn't register as something has actually been put in. So increasing this number again shouldn't be needed, but it does help make our code function more the way we want it to. Next thing I'm going to do is I'm going to right click on read pulse here, then click duplicate, snap it into the spot underneath it, and change the pin to A1. So in the previous video, I mentioned that channel 1 is our forward and backwards or vertical axis on the right stick, and channel 2 is our horizontal or left-right axis on the right stick. I referred to them as axis 0 and axis 1. That's just because 0 again on our list right here refers to this first spot. 0 refers to the first spot. 1, the index value, refers to this second spot right here. Sorry for the stuttering and stammering. I'm going to duplicate again. snap this into place, change it to axis 2, axis 2, channel 3. It's channel 3, but it's axis 2. This one is on our left stick. It's by default is going to be our left, right, or horizontal axis. If I duplicate again, set it to A3. That's going to be the forward back or vertical axis on the left stick. Duplicate again, and again. These last two I'm going to set the pins A4 and A5. Oops. And these are the two switches at the top of the controller. Now, all of these values should be in a range between 1000 and 2000. That's just what they come in on from the Flysky whenever we read the raw values. 1000 to 2000, it's not a range that we really like working with, but we will normalize this in our next thing that we do. Well, almost next thing. I got one more thing in the setup we need to do before we move on though. So I'm going to click on variables right here, and you'll see I've got set dead zone right here. I kind of goofed and had already created the dead zone variable, but if you click create variable, again, just like with the list, it asks you to give it a name. I'm calling this first variable dead zone, right? After creating the variable, these will populate on your list right here. I'm going to drag set dead zone to right underneath my input values, and I'm going to change this value after it to negative 0.05. For those of you who are not familiar with what dead zones are, we see these used a lot in video games and any type of system where we have an analog user input. So basically what's going on here is we're defining a range on the controller where the controller is not responsive to things that are happening, to any type of input happening to it, which sounds like a bad thing, but what you'll notice is if you were to just read the raw values, especially with these Flysky controllers, of just about every controller, if you just read the raw values, very rarely does it just stay static on a number. It'll jitter back and forth, higher, lower values. And our dead zone is allowing us to set a range that we ignore the little minuscule change that's happening so that we don't get that jitter within our program. I've set this to negative 0.05 here. That's a value that I found that works great with the controller that I have. Each one of you, when you're programming your controller, you will want to test it out and find a value that works good for you and eliminates the jitter from happening. The negative value right here, that's set to negative. Normally when you see dead zone values inside of your programs, it's always a positive value, never a negative value. I put a negative value there for a couple of purposes, and I'll explain that once I get to it. So our setup here is done. I'm going to click on functions, and then right here we have two different types of functions. We have a void function and we have a return function. A void function, you'll see it says function with no output. So a void function, when you call on a void function, it's going to do its thing, and then once it's done doing its thing, the original part of the script that called on it will proceed on to the next line. A return function, just like a void function, will do its thing, but then it's going to take a value that it finishes the function with and sends it back to this part of the script that was calling on it for it to do something to it. Most often it's going to be taking the return and assigning it to some variable, or taking the return to do some type of truth check to see if something is needing to be done in an if statement. In all of our script for this particular project, for the example of the controls I'm giving you, we're just going to stick with the voids. So I'm just going to drag this top one in, set it right here, and instead of do something, I'm going to call that get remote values. I'm calling it get remote values because when you're working inside programming professionally, the people you work with, it's really beneficial to them if when you make your code, they can just look at it and read it and understand what's going on. So I've called it get remote values. That tells you that this particular function is going to get the values from the remote that the remote's sending to our receiver. Now we've done that up here already, but like I said before, the setup function happens exactly one time. So after it does this initial read, this bit right here is not happening again. So what we want to do is we want to create a function that's going to keep reading that over and over and over again and call on that. Well, it's going to keep reading it, calling on it in the loop so that it'll keep happening over and over again, and we have constant control over our robot. So now if we click on lists right here, we're going to grab this. This is a set function or an assign function. You'll hear me refer to the equal sign, a single equal sign, as assign quite often. Input values right here. This is the list we're calling on. I only have one list right here, so this is the only thing I can add it to. Set right here, this is our index value. Whatever number right here is which one of these spots. We are going to override the value that's currently there with a new value. So if I set this to 0, our index value 0 right here is going to be whatever number is on this side of that little equal sign, the assign symbol. Now again, this is where copy and paste loves us, because we can just right click on that, click duplicate, and drop this right there. And what this is going to do is it's going to read that pin 0 once again, just like it did up here, and assign the new value in here. So if you happen to start pushing forward on this, it's going to change whatever index value 0 of input values is to correspond to how far forward you are pushing it. So I'm going to right click on that. I'm going to click duplicate. And I want to change index value to 1 so that we've got our second number being set. And instead of pin A0, we're going to change it to 1. And we're going to rinse and repeat for all 6 axes. There we go. So every time this function's called on, it's going to take a look at each one of these index values and assign them a new value based off of the 6 different axes we're receiving from the remote. Now, the Flysky remote, by default, the values are going to be between 1000 and 2000. I do not like those values. If you're in game design, or if you're in most computer programming disciplines, user input is usually best put into a range between -1 and 1, because a lot of the code we do, we're going to be running various math functions where we want to use our input as some type of multiplier to whatever raw value our maximum or our minimum of an action should be. So like if you're thinking about characters running in a video game, you're holding on the left stick, you're pushing it forward. If you push it all the way forward, your character's running at their maximum speed. But if you start easing up on the stick just a little bit, your character starts slowing down, but it doesn't come to a complete stop until you completely remove your thumb from the stick, right? So those values, those in-between values, it's easier to use if those values are between 0 and 1, because if we multiply our maximum speed of, say, 10, let's say our character can run 10 meters per second, all the way forward, 10 times 1 is going to be 10. If we have it about halfway, it's going to be 0.5 times 10. 0.5 times 10 is 0.5. And I'm sorry, it's not 0.5. 0.5 times 10 is 5. God help me, I keeps messing up on stuff today. Sorry. So halfway forward, our character is running at their half speed. If we go 75% forward, our value is going to be 0.75. 10 times 0.75 is 7.5. So our character is going to be running at 7.5 meters per second. If we want our character to run backwards, we've got those same values in there. I'm assuming our character can run at 10 meters per second backwards, which is really impressive if someone can actually run 10 meters per second backwards. But again, -1, that tells the negative sign tells us we're running backwards, and the 1 tells us it's going to be full speed backwards. So our 10 times -1, we're running backwards 10 meters per second. A lot of rambling there, sorry. Now again, our input values are coming in at 1,000 to 2,000, somewhere in that range. Truth be told, again, they actually extend a little bit under or a little bit over based off of your remote, just manufacturing defects or variables. However, they will be close enough to work, but we have a little bit of code that we're going to be adding in that fixes being outside of our valid ranges and takes our 1,000 to 2,000 range and remaps it down to a range of between -1 and 1. So in normalizing our values to the ranges and values we need for the rest of our script, what we're going to do is we're going to go over here to Control, and we're going to drag count width into our scene. And you'll see it says count width I from 0 to 9 by 1. So that just created a variable for us called I. If I click right here, you'll see I is now an option that we can drag and add in, as well as dead zone. So I, depending who you ask, will stand for integer or iteration. You will usually see this from programmers whenever they're doing some type of loop within their code. And by loop, I am not referring to this runtime loop here. I'm referring to a segment of code that will just keep repeating until a certain condition is met. And then once that condition is met, it will break out of the loop and continue on with the rest of the code. Now, this particular one is going to only run a certain number of times. So if we start at 0, and then if I write down 5 here, what this is going to do is it's going to start at the value 0, and it's going to run through this loop as many times as it takes in order it's going to take the 0, it's going to add this value right here, and it's going to run through the loop as many times as it takes to go from this number to this number by whatever number is right here. So I have 1 there right now, but if I were to put a 5 there, if I put a 5 there, this loop will happen twice. Once for when it's at 0, once when it's at 5. If I put a 10 here, it's only going to happen once, because it'll happen once at the 0, but after that we're well past the 5. It's never going to hit 5 now, so the loop should end. I'm going to leave it at 1 because I can't think of any sane reason to use anything but 1 for this particular thing, but I'm sure someone has a use for it. So what we're going to be doing is we're just going to be counting from 0 to 5, because 0, we're going to be feeding our input values in. We want the functions happening in here, which will help normalize our inputs, to be fed back into our input values here. So 0 to 5, increase by 1. This loop will happen 6 times. Once for 0, once for each one of the axes. And then once it's finished on that 6th time, the loop will come to an end. So now what I'm going to do is come up here to lists. I'm going to put this set value here. So we got our set input values. And for our index value, instead of a number, what I'm going to do is I'm going to come to my variables and I'm going to drag I out of here and set it right there. So whatever I is, it's going to use that number to know which one of these inputs we are writing a new value to. So on our first passive loop, input value 0, it's going to be overriding whatever's right here with whatever value we end up putting right here. So from there, we're going to do a little math. So come up here to math, and we're going to drag this one right here. This has a plus operator by default, but if you click this button right here, you can see the other operators we can use. We have plus, minus, multiplication, divide, and to the power of. We're going to snap this in right here. So whatever goes into this spot right here, what I want to do is adjust it by whatever value goes here. See if I remember right. Give me one moment here. Yeah, right. Sorry. Getting ahead of myself a little bit. I'm going to go ahead and duplicate this again. And this I'm going to put into this first spot. So this will work kind of like parentheses when you're doing your math. We do whatever's in the parentheses first. And if there's parentheses inside of parentheses, we do the things that are in those innermost parentheses. So now we've got this bit that's going to happen before this bit right here. So what I want to do here is I want to take our current input value for this particular iteration. So if I go up to lists and you grab get right here, this is going to get our input value. Again, we want to use I for the particular index array value. So whichever iteration of the loop we're on, it's going to be affecting that specific value. It's going to be grabbing it. It's going to be setting it. So at the moment, this isn't changed until whatever happens over here happens first. So we're grabbing our value, and then we are going to subtract a numeric value. So I'm going to go up to math. I'm going to grab my number here, drop it right there. And I'm going to set that to 1,500. 1,500 sounds a little bit arbitrary, but again, our default values we're receiving from the controller are between 1,000 and 2,000. 1,500 is the value that we should be receiving if you are not pushing on the stick, meaning it's in its neutral position. This right here is just going to take its neutral position and drop it down to 0. So now whatever value is in this particular spot would be between -500 and 500 if we just left it alone from here. We're not going to leave it alone though. I'm going to add another number spot right here, and I'm going to type in 500 here. And instead of plus, I'm going to change that to divide. So whatever number between -500 and 500 we receive from this operation right here, we're going to divide that number by 500, so we'll now have a number that's somewhere between -1 and 1. This is just remapping our values. Now again, this is an in theory thing. In practice, because the remotes have various defects to them, our values may be just a touch over 1 or a touch under 1. So that's what our next bit of code is going to help us with. Well, not quite the next bit, but after this next bit, sorry. Next thing I want to do is I want to go ahead and make use of our dead zone. So I'm going to come up here to logic. I'm going to drag an if in right here. So whatever value we've got right here, I want to do a check to see if it's falling within our dead zone, meaning the value, is this the value where we want the remote to actually do nothing as opposed to doing something. So with an if check, We want to come up to logic, and here's our comparisons. I'm going to put an and in here because there's two comparisons I want to do. I want to first check to see if the value is greater than negative 0.05, because anything underneath that number is going to be outside of our dead zone range. And the other thing I want to do is check to see if it's less than 0.05, because anything over that number is going to be outside of our dead zone range. So we just want we just want to check to see if the value is within that negative 0.5, I'm sorry, negative 0.05 and the positive 0.05 range. Little trouble talking there, sorry. So we're going to come back up here to logic, and we're going to grab our comparison right here, our comparison operators, and drop that right there. So like I said, we're going to grab our input values right here. So we're just going to duplicate that because we're going to keep using it over and over and over again. We change our thing right here to less than, which is right here. For those of you who aren't aware, this one means not equal to. This is less than or equal to, greater than or equal to. After that, we're going to come up here to our variables. We're going to grab this right here and feed it into the second value. But instead of I'm going to click this down button and select dead zone. So now it's checking to see if it's less than our dead zone, which happens to be negative 0.75. After that, I'm just going to right click and I'm going to duplicate, drag it over here, change this to greater than. And there's two ways we can do this next bit. First, I'm going to drag the dead zone off. Both ways are going to involve a little bit of math, and it's math that the computer is going to do for you, so life is going to be nice and easy. Now, one of them, we can take our dead zone and we can multiply it by -1 to get the positive version of our dead zone. Alternatively, if we click on math and we grab this one right here that by default says square root, drag it in. We don't want square root, but if we hit this little down button right here, we've got absolute right here. I'm going to drag our little dead zone, connect it there, and put that right there. So now we have, if our input values I is greater than the absolute dead zone value, then we are going to be doing whatever's in our do function here, so long as it's, I'm sorry, got this backwards, sorry. This should be less than, this should be greater than. This is making sure we are greater than our dead zone. This is making sure we are less than the absolute value of our dead zone, putting us in our range. Sorry about getting that backwards there. Anyways, so this is going to check our range here. And like I said before, I put negative 0.05 right here for our dead zone. Reason why I did that is because I found it kind of funny to put absolute dead zone in our code. And also I could do this instead of having to do dead zone times -1. So now, if we're within the dead zone, what we're going to do is we're going to grab our lists right here. Then we're going to set value. So drag that, set it inside the do. And once again, we're going to put our iteration value right there. So make sure we're still working with the same number on this particular loop. And then for this value right here, we're just going to leave that at 0. Because anything between negative 0.05 and positive 0.05, we want it to be a 0, so when we multiply our force effects or our variables that we use later on, we get 0, so it does nothing. After that, we want to do a little bit of normalization on the flaws with the remote where we take our value and make sure it's not greater than 1 and not greater than -1. I'm sorry, less than -1. And that one's going to be relatively simple. So once again, we're going to go to Logic, drag that, place it right underneath. And then let's just go ahead and duplicate this right here because it makes life easier to duplicate it. So we've got our input variable right here. We're going to check to see if it is greater than, not dead zone anymore. We need a number type of component to block to put in here. We're just going to check to see if it's greater than 1. If it is greater than 1, let's duplicate this, put it right there. It doesn't really matter whether it is 1.05 or 1.5 or 17,000. Well, if you get 17,000, you've got a big problem with the controller, but everything else, I mean, within reasonable error range. But anyways, if it's greater than 1, we want to set the value to 1. That way we're just clamping our maximum value to 1, so that way when we feed our code in later, we're not overloading the motors, which will cause them to get confused and just shut down. I'm going to duplicate this if function right here, and you see all the blocks that were attached to it come with it. I'm going to drop this right underneath, change my sign to less than, change the value to -1, and then on our do section, we're going to change that to -1 as well. So if our value is for some reason less than -1, we're putting it at -1. So same reason we did that up here, just to make sure that nothing breaks. And that covers this function right here. So at the moment, your code should look something like this. You got our setup and we got our get remote values right here. Now the get remote values function is not being called on currently. Now that's what our next step is going to be. We're going to make sure that we can call on that function and have it do something. So what we're going to do is we're going to click on functions right here, and you'll see get remote functions is now showing up on our list. If I take this and I drag it and I just put it right at the top of my loop, every single time this code executes its runtime loop, it's going to do everything right here, because that's what this function is telling it to do. Last little bit I want to do for this particular bit of the video is I'm going to come over to the loop here. I'm going to add another logic function in here. I'm going to put it right underneath the get remote values. And then I want to do an equality check. So if I come up here to logic, I'm going to drag this one in, put it right there. Then I'm going to come up here to lists. I want to take a look at two of our variables. So if I do our gets for our input values, drop that right there. I want to take a look at our axis 4 and our axis 5. So axis 4 right there. I'm going to duplicate that. Axis 5. And it occurs to me that I grabbed the wrong function here. So let's pull that off, move that off, kill that, come back up to logic, and I want the if, do, else. So the way this works, with an if function, whatever goes right here, it's going to do a truth check. If everything in here is true, it's going to do whatever is in the do category. However, if this comes back false, it's going to do whatever is in the else category. So what I want to do is I want to check to see if axis 4 and axis 5 are the same value. Now, because these are switches, there are only two values we should receive from them. If both switches are up, the way the Flysky controller works, we're going to get a value of 1. So it'll be a value of 1 for axis 4 and a value of 1 for axis 5. If both switches are down, the value we receive should be 0. So I'm sorry, if one of the switches, if the switch is down, the value should be 0. So if both are down, it'll be 0, 0. We do what's in here. But if one is up and one is down, we'd get, say, 4 is 1 and then 5 is 0. The equality check here, it comes back false. So instead of doing what's here, we're going to do what's in the else category. And this is working for our kill switch right here. Kill switch is just basically a method of making sure the robot doesn't do stuff when we don't want it to, such as turn on its weapon system as soon as you turn on the robot while your hands are still within range. The kill switch is going to keep us safe. So it's kind of important that we make sure we get this bit of code right. So I'm going to come over here to functions, and I'm going to create 2 more functions in preparation for the next video. So this one I'm going to call drive code. This function is just going to be what controls our robot. The second function here, I'm going to call other functions. I'm just going to drag that to the side here. So then, if the way our kill switch is going to work for this robot is unless you have one of the 2 switches up and one of the switches down, the robot's not going to do anything. So we want to leave this do category blank. The reason why we're doing this with 1 switch up and 1 switch down, in order to turn on the controller, in order to connect it to the transceiver, the controller requires all 4 of those switches up. However, if you lose communications to the robot between the robot and the controller, the value is going to default to 0, because 0, null, that is our default value for every variable type. Well, I should say almost every variable type, because as soon as I talk in absolutes, someone's going to tell me I'm wrong. Anyways, so if we're checking for an inequality here, this is something we have a little bit of control over, because if we lose communications to the controller, both values will be 0. When we first turn it on, both values are 1. When we first turn it on, we don't want the weapon system activating because, again, our hands are still near the robot and we don't want to get hurt. And if we lose communications to the robot, we don't want it to be doing anything, because if we lose communications, something's gone wrong, we need to go up to the robot and handle it. And again, we don't want to get hurt. So we're doing an inequality check. I'm sorry, an equality check. If they come back unequal, false, we're going to do whatever's in our else. So for our functions right here, we're going to put our drive code there and our other functions right here. Now, right now, these 2 functions do nothing. Our next video, we'll be putting something into the drive code. The other functions, though, is the function that you'll be using for your robot-specific things that you add in. So if you have a sensor that needs to be checked every time in the loop, you'll put it in the other functions. If you have a weapon that needs to only sometimes be active based off of what the sensors are feeding in, again, you'll put that in the other functions, or you'll make your own function and feed it into the other functions. This just keeps our code, again, readable and clean. So when you look at the loop, you know exactly what's happening. First off, it gets the remote values. Second, it checks to see what these 2 axes are. Third, if they're equal, we're going to do nothing. If they're not equal, our robot's in fight mode. And that's going to be the end for this video. Again, the next video we'll be diving into the drive code, which will hopefully be a little bit easier. Thank you very much.